All right, welcome everybody. This is Noah, and in this video, we're going to look at how to graph a quadratic function that is given in vertex form. All right, for our examples that we're going to look at here, let's read the instructions. It says, given the following functions given in vertex form, find the vertex, the y-intercept's mirror point, the x-intercepts, and two additional points, then graph the function. I'm actually going to move this down, I think. There. Sorry, a little reorganization, realizing that this will fit a little better here. Oh, don't want that to happen. All right, thanks for your patience there. Let's see, so we have f of x equals 3 times the quantity x minus 2 squared plus 1. Let's begin by identifying the vertex. So the vertex is the point 2, 1. For the inside, it's the opposite sign. For the outside, it's that positive one. It's the same sign. And then we want to find the y-intercept and its mirror. So the y-intercept, we're going to plug 0 in for x. So we'll get 3 times negative 2 squared plus 1. Work through this. This is 3 times a positive 4. That square cancels that negative out. We'll add the 1 after that, so this will be 13 total. 3 times 4 is 12, plus 1 is 13. So our y-intercept is the point 0, 13. And we know that this graph is opening up with a stretch factor of 3, right? The y values are being stretched by 3. So let's see here. Start graphing this, and that'll help us determine the y-intercept's mirror point. The vertex is at 2, 1, and it opens up, so I really don't need much, if any, negative values at all. The y-intercept is 13. So let's see. I've got 5, 10, 13. It's there. That'll work. So we can just go by ones in the y direction. In the x direction, let's stretch it out just a little bit. Let's do 2, 4, 6, negative 2. Because the 3 for that a value, the y stretch, we're not asked for this, but it's good to kind of be aware of it. The y stretch is 3, so it's going to be skinnier. So if I stretch the x scale out a bit, whoops, that should be negative 2, not 6, then I should be able to, I don't know, make the graph just look a little bit nicer, since that y stretch is kind of pulling it up as much as it is. So let's plot what we have so far. The point 2, 1 is right here. That's our vertex. The y-intercept is 0, 13. That's over on the y-axis, up 13, 0, 13. And so then here's the axis of symmetry is when x is 2. So if I take this point and reflect it over that, then it'll be out here. This is the point 4, 13. So there's our y-intercept mirror. Intercept mirror is the point 4, 13. All right, there are no x-intercepts here. And I can see that because this is an upward-facing parabola, and that vertex is already above the x-axis. So we're not going to be hitting the x-axis at all. We could check that. We could try. If I hit 0 equals 3 times x minus 2 squared plus 1, If I subtract the 1 and then divide by 3, well, let's do this in steps. Negative 1 equals 3 times x minus 2 squared. Then we would divide the 3 over to get negative 1/3 equals x minus 2 squared. But then when I try and take the square root of both sides, don't forget the plus or minus, when we do that, this left side is undefined, right? It's not a real number. I'll say that. Not real. So there's no solutions. So there's no x-intercepts. All right, it does say to find 2 additional points. So I think I want to plug in like 1. If x is 1, I want to find where the point is kind of between the y-intercept and the vertex to help me clean this up a little bit. So if I do f of 1, plugging in 1 for x, I get 3 times 1 minus 2 squared, and then we'll do a plus 1. This will be 3 times negative 1 squared plus 1. Negative 1 squared is just a 1, so this will be 3 times 1 plus 1 equals 4. So we have the point 1, 4 is right here, and we can reflect this over that axis of symmetry to get this point 3, 4. So we can go ahead and now draw our parabola through these 5 points. Label the function y equals f of x. And I think we're good. Yeah, that's everything we need for this. So, all right, there's our first problem. And we're going to do that one more time with a different function, get a little bit more practice from this explanation here. Part B, we have g of x equals negative 1/3 times x plus 2 squared minus 4. So we'll start with the vertex. The vertex is negative 2, negative 4. Right? It's the opposite sign for that inside, for the x. The x is shifting left 2. The y stretch equals negative 1/3, so this is opening downward. And I want to get that y-intercept, g. I'm going to plug in 0 for x here. I'll get negative 1/3 times 0 plus 2 squared minus 4. And we just need to work this out. So negative 1/3 times 2 squared minus 4. So it'll be negative 1/3 times 4 minus 4. To do multiplication first, this is negative 4/3 minus, and then I want to get a common denominator, so I want a 3 here. So if I had that 4 above, that was over 1, so I multiply top and bottom by 3 to put a 12 over 3 there. So this will simplify to negative 16 over 3. And it's nice to have that as a mixed number. 3 goes into 16 5 times with 1 left over, so negative 5 and 1/3. So our y-intercept is going to be the point 0, negative 5 and 1/3. Let's go ahead and find the x-intercepts now. So I know before I graphed at this point here, I'm going to check for the x-intercepts first, just so I know how much space this is going to take, honestly, because the x-intercepts can take up a little bit of space, and I don't want to draw my graph in a way that's going to get in the way. So 0 equals negative 1/3 times x plus 2 squared minus 4. So we'll add the 4 to the left first. So 4 equals negative 1/3 times x plus 2 squared. And then we're going to multiply both sides by negative 3. So so that we clear out that negative 1/3 in the front. So this would be negative 12 equals x plus 2 squared. And this is happening again. I didn't necessarily intend this, but this can happen. If I take the square root of both sides now, don't forget that plus or minus when we take the square root of both sides, then again, this is not real because I can't take the square root of a negative. So no x-intercepts. Cool. All right, well, that saves us a little time. Let's go ahead and plot what we do have. And then we'll determine 2 additional points to kind of fill in the gap from those x-intercepts not being there. Okay, the vertex is at negative 2, negative 4. So the y value is at negative 4 already, and it's opening down. Yeah, and we can see from that that we shouldn't be expecting to get an x-intercept now that I'm looking at that and thinking about it a little bit more. So the vertex is below the x-axis, and it's opening down. X here. The y-intercept's at negative 5/3. I think because that y-intercept's relatively small, especially with all the space I have here, I'm going to make this oops, not there. Go and say that this is negative 1, negative 2 is here. So I'm stretching the y-axis down. Negative 4. In fact, actually, since that's a 1/3 right there, since the y-intercept is negative 5 1/3, let's go by 1/3 for each of the grid lines. Oops. So that means I'm going to go negative 2 here, negative 4 here. That's negative 5. All right, and then in the x direction, I think we can stretch this out in the x direction as well. Let's do negative 2, negative 4, 2. Okay. So now we can plot that vertex. Negative 2, negative 4 is all the way down here. And then the y-intercept is at 0, and then negative 5 and 1/3. It's here, oops. 0, negative 5 and 1/3. And this was negative 2, negative 4. And then the y-intercept's mirror point is going to go over that axis of symmetry to over here. And this is the point negative 4, negative 5 and 1/3. So we can really start drawing this parabola at this point, but we want to get a couple more points just to make this a little nicer. So the question is, what do we want to plug in? Well, I could plug in negative 1 or like negative 3. I think I want to plug in positive 1, though. I'm going to make this, I'm going to go for something over here and then find its mirror point off to the left. So if I plug in 1 for x, g of 1 is going to equal negative 1/3 times 1 plus 2 is 3 squared minus 4. This would be negative 1/3 times 9 and then minus 4. Negative 1/3 times 9, that's negative 3, and then we need to subtract 4, and we get negative 7 out of that. Cool. This is negative 6, so negative 7 is here. So 1, negative 7 is right there. And then I can find its mirror. So that's going to be over that axis of symmetry, same distance. It's going to end up there. So this is going to be, what's that, negative 5, right? Go. we'll just add to our parabola a bit, clean it up. Label the function y equals g of x. Our y-axis, forgot that earlier. And there we go. That is the whole graph. So we've found all of the required things asked for in the problem. We've labeled our points. We've labeled the function. We've got a nice problems to give a go at. Go ahead and work on those, and in the next video we'll run through those solutions. Thanks so much for watching. We'll see you shortly.